So we're going to begin. The lessons in Introduction to Algebra that we are going to be focusing on are lessons 9.2, 9.3, 10.3, and 11.3. Those are the 3 lessons on combining fractions. When we originally wrote the program, we only had 2 lessons on combining fractions. And in our field test, the teachers asked us to include more. And so we did expand the fraction, addition, and subtraction lesson. Even still, we wrote these a few times. And I must say, honestly, and there's only 2 of you, so I can say this, but I'm still not 100% happy with the way these lessons came out. I think we could have done even a better job. And one of the things I want to share with you today is how I think you can make them better in the classroom by enhancing some of the things that we've done. So that's one of the things that we're going to be doing today. So the goals for our session today are going to be that we're going to be reviewing fraction concepts that are essential for adding and subtracting fractions. And I hope that I can make a case for you today for why we are reteaching addition and subtraction in the middle school using a more algebraic approach rather than the standard algorithmic approach that is used in most textbooks. One of the things that I have often spouted out is that I wish that in the elementary school, students would learn everything there is to know about fractions except how to procedurally add, subtract, multiply, and divide them. And I believe that if students came to the 6th or 7th grade with those skills, the 6th or 7th grade teachers would be quite happy. I don't know whether you agree or disagree. You might want to give me a thumbs up or a thumbs down, or I'm not sure if you agree with that crazy statement. Thank you, Pat. I really think that it's the fraction concepts, if the students understand those, that teaching the procedures becomes relatively easy. And so what I want to do today is share with you an algebraic way to add and subtract fractions, but more importantly, take a look at the concepts that are needed in order to be able to do this. They are all included in the program. I will admit some of them have been included, I think, more explicitly than others. And there is a handout for this session that Joe will be emailing to you that has a list of all of the concepts that I think are really important for students to have facility with before they work with operations with fractions. And I will encourage you to use that to come up with extra warm-ups. Joe, what do you have to say? Moderator, would you like me to send that now? Yes, I would like you to send it now for them. Thank you. We're going to go to the next page. All right, so some of the big idea fraction concepts that are so important are, here are 3 of them, and there are some more. One of them is using the big one to rename fractions, and that was one of the warm-up skills that we had in the While You Were Waiting activity. And I believe that in the program we do a pretty good job of working with the big one, with splitting and replicating and renaming fractions in different ways. But this is obviously a very important skill when you're going to combine fractions. Another one that is very important is being able to write fractions in different representations, to be able to write them as what are traditionally called mixed numbers and improper fractions, although I don't like that word improper because it seems like it's not improper that they be written this way, but that's just me. But the students should be able to write them this way, and they also need to be able to find the opposites. They need to be able to have a sense of where 1 3/5 is on the number line and where negative 1 3/5 is on the number line. And we'll get to more of that later. Another skill that they need to have is to be able to subtract a fraction from a whole number. I see this as mental math, and I would hope that the students could see this as mental math as well. initially subtracting from 1 and then expanding that skill to being able to subtract from any whole number. And again, Pat had written in the chat window earlier that she felt that her students would do this by thinking about what number plus 2/3 equals 1. And that's a very nice way to think about it. Thank you, Pat, for that idea. Okay, so I said earlier that I would like to see students add fractions using similar processes that they would use if they were adding rational numbers algebraically. And the reason that I think this is important is because when we teach students to add fractions using algebraic procedures, then they are going to have something to connect to when they get to algebra and need to manipulate rational numbers. And I really see no reason why we cannot do it that way, especially in the middle school when we're reteaching. And that way the students will already have these skills in place, and doing it with variables just extends what they already know. So this is what I mean by doing it algebraically to begin with. We're going to look at a problem that's lined up vertically and then write it horizontally. Now, does anybody see anything in this representation that looks a little strange? Put it out in the chat box if you like. Some people find that the writing of the fraction 3 1/2 as 3 plus 1/2 is kind of unusual. And I think actually that's a really important piece of this procedure, because students often do not think about the fraction 3 1/2 and 2 5/6 as really the sum of two fractions, 3 plus 1/2 and 2 plus 1/6. Now, one of the reasons that this can be confusing for students is because there are multiple ways that we write algebraic or numerical expressions where we put two symbols together, but they have different meanings. In this case, we are putting the two symbols together and we add them. But normally, like Pat says, when we put two symbols together, it means multiply, like 3x. The 3 and the x are implied to be multiplied together. There's actually another way that we put symbols together that might even feel more confusing to the students. Anybody have an idea what that is? I'll give you a little hint. Think about the number 14. In the number 14, what do the two symbols mean? Any ideas? Oh, you folks are so quiet. Thank you, Helen. Yeah, the 1 there actually represents a 10, and the 4 represents 1. So there's students in middle school have seen this symbolization for a long time, and it means, 1 times 10 plus 4. Then we throw in 3x, which means 3 times x, and 3 1/2, which means 3 plus 1/2. All part of the confusion of the conventions of algebra, and writing fractions this way is going to help them to learn to interpret those different ways. Okay, we move on. So suppose we wanted to add fractions horizontally. I have deliberately done this example quite expanded, probably with more lines than are needed. But I've done this for emphasis because I wanted to show you what this might look like. I want you to notice how the properties of arithmetic are more transparent in this method. Notice that in line 1, I've used the associative and commutative properties to rearrange. I see that Joe has a question. Joe, what's your question? Oh, please address Susan's question. Oh, Susan, won't they think they can multiply the same way? I'm not sure I understand your question, Susan. Do you mean multiply by saying that 3 1/2 times 2 1/6 is 3 plus 1/2 times 2 plus 1/6? Is that what you're talking about? I'm waiting for students to come through on my monitor. So I'm just going to kind of chat until I see that. No, like 2 times 3 and 5/6 times 1/2. Oh, interesting. It's possible that they may want to do that, I suppose. But actually, if they multiply 3 plus 1/2 times 2 plus 1/6, they would need to apply the distributive property in the same way that when we were doing the we were doing the area model for multiplication, 12 times 13 was 10 plus 2 and 12 plus 3. So I think that, again, we have to rely on the rules of arithmetic and help the students to see that this is more parallel to the multiplying 12 times 13 than it is just multiplying the pieces together. I'm going to move on from there. I hope that answered your question. Yeah, they might get mixed up, but they get mixed up with fractions anyway. So we're just trying to help them to have some mathematical rules to rely on to help them not get mixed up. So anyway, we're going to move on. I'm going to explain this, and I thank you for your questions. These are good ones. First, we rearrange the problem in some way so that the computation will be simpler, and that's what's been done in line 1. And then in line 2, notice that we're using the big 1, the multiplication property of 1, to find a common denominator so that we can add those fractions together. In lines 3, 4, and 5, and I did write these out in some detail, you can see that we're using our fraction concept ideas, the ideas of being able to write fractions in flexible ways and rename them in different ways in order to combine. And then in line 6, here we see the big 1 again. Now instead of multiplying by 1, we're dividing by 1. And then finally in 7 and 8, once again, we're using our fraction concept skills to combine 6 plus 1/3 to get 6 and 1/3. So this is what it would look like algebraically. And this is the procedure that one would use if they were combining fractions that were algebraic or rational number fractions as well. Okay. Once again, I just want to reiterate that we're looking at some of the fraction concepts that are needed in order for students to be able to perform operations this way. And 2 of them are the big one, of course, the idea that we can rename fractions using the multiplication property of 1. In the warm-up, you saw some splitting and replicating diagrams. I thought here I would show you what it looks like if you're going in reverse. If we're trying to rename 4/6 as 2/3, we would be using some sort of grouping diagram to show that we have 2 parts out of 3 is equivalent to 4 parts out of 6. Another important skill is the ability to write different representations of numbers, and you can see 5 different representations of 1 and 2/3 here as pictures in the number line. The sum, of course, is very important because that's what we're going to use when we go to add an algebraic way. If your students are having difficulty with these skills, I would recommend that when you have a few minutes at the beginning or middle or end of class, that you just put one of these charts up on the board with some of the representations filled in and have the students fill in the rest. And just give them practice like that. And that is what your handout looks like that Joe sent to you. Okay, now it's your turn. I'm going to give you a chance to try to add fractions this way. The 3 steps are to write the problem horizontally and to write each fraction in expanded form, and then flexibly combine the terms using properties of arithmetic. I'm going to be quiet for a minute. I'm going to let Joe turn on the 1-minute timer. And after you do the problem, if you have some time, if you would write in the chat box what you think about this procedure, that would be great. If you just do this on your own paper, it'll be fine. I think writing it on the whiteboard is going to be a little bit difficult. Okay, I hope that you had a little bit of time to think about that problem. If you have any thoughts about the procedure, go ahead and write it in the chat window. And I have put together a possible solution here for us to take a look at. Notice that once the problem has been written in fraction expanded form, combining the whole numbers and the fractions seems pretty natural. Changing those fractions to have common denominators, of course, is essential. And then combining the fractions, renaming them as an improper fraction and then a whole number plus a fraction. And then finally, leaving it as a mixed number. It's just one way to do it. In algebra, actually, we would pay more attention to what I guess you would call the improper fraction mode, and we're quite happy with fractions that are just a numerator and a denominator and don't have a mixed number part. Any comments or thoughts about that? Catherine, I see that you're writing and I'll be looking. Okay, that sounds like a nice idea. Have the students change 11 tenths to 10 tenths plus 1 tenth as an added step. So that would even be another step. It does take more paper and pencil, but I think that when students learn to write all the steps, that is an important skill that's going to serve them well in algebra. Okay, we're going to move on now to subtraction. I'm sure you've been wondering how we're going to do that. Again, there are certain concepts that are essential to being able to handle subtraction. One of them is being able to find the opposite of a fraction on and understanding what that means. And so if someone would be willing to write in what the opposite of a fraction is of 3/4, and perhaps someone else might put 3/4 and negative 3/4 on the number line, that would be great. For 1 2/3, I invite someone to go ahead and write the improper fraction for 1 2/3 and to place negative 1 2/3 on the number line. And as you're doing that, I will acknowledge that clearly writing negative 1 2/3 as a sum or a difference is the sticky point that's going to be a place where an important concept gets developed. Anybody know what property is being applied here? I'm going to write it in the chat box. It's an important property of mathematics that is being used here, and we're going to use that to make our subtraction problem look algebraic. It is a distributive property, Helen. We're finding the opposite of a sum, and it's like think about multiplying that sum by negative 1. We might write the opposite of 1 2/3 as negative 1 plus negative 2/3, or as negative 1 minus 2/3. Now, nobody put the point on the number line, so I will here. Negative 1 2/3 is located there. So the reason it's so important for students to be able to find a number and its opposite is because this distributive property example here is much clearer to students if they look at the number on the number line. Clearly, I think you can see that if we go from 0 to negative 1, that's negative 1. and then we have to continue negative 2/3 in order to get to negative 1 2/3. And so the number line actually is a nice way to convince students that negative 5/3 or negative 1 2/3 is really negative 1 minus 2/3 or negative 1 plus negative 2/3. I acknowledge up front this is tricky, but I also acknowledge up front that if we can begin to develop this idea of how to take the opposite of the sum in our algebra readiness classes, students are going to be much better prepared for algebra, and after all, that is one of our major goals. Okay, another concept that is going to be important, I alluded to earlier, is being able to subtract from a whole number. And this is something that students should be able to do mentally. If they start doing the whole borrowing and trading thing, that's where students tend to make mistakes. But if they can mentally think about what 1 minus 5/6 is, that is 1/6, or any whole number minus a fraction is, that's going to serve them well when they start subtracting fractions, and we'll see why in just a minute. Okay, so let's see what this looks like when we subtract fractions. First of all, we're going to go ahead and write them horizontally. And then comes the tricky part, of course, that when we subtract 2 and 5/6, we're really subtracting 2, and then we're also subtracting 5/6. Or you might think about it as adding negative 2 and adding negative 5/6. Clearly, that's going to take lots of conversation and lots of discussion, but once students have that idea in place, subtracting fractions is going to be easy. Let's take a look at an example. So here's our problem, and in the interest of time, I think I'm not going to have you do this. I think we'll just go ahead and go to the solution. Unless you'd like to try it. Give me a happy face if you'd like to try it before we go on. How about a clap if you want to go on? Okay. Catherine, you have a question. Okay, so we're going to go on. So let's take a look at what this one looks like. When we go ahead and subtract this one, again, we're going to want to combine the fractions in a way that makes sense so that our computation is as easy as possible. And there's lots of ways to do it, and you'll have lots of interesting conversations in class about how students choose to do it. But the way that I did it here, just for the example, is I actually subtracted the 3 minus 2 first and got a 1. And then I subtracted the 1 minus 5/6. That's an easy problem, 1 minus 5/6. And look what happens. Once we have these basic algebraic notions in place, we've turned that complicated regrouping fraction problem into a relatively simple addition problem that looks very much like just a simple little combining fraction problem, where we use the big 1, combine the fractions, and come up with a result. So using a little bit of mathematical common sense when you're subtracting fractions, once it's set up, it's going to make the fraction operations much simpler. I would encourage you to give this a try. The materials are set up so that students will ultimately be doing addition and subtraction horizontally. But like I said before, I think that those preliminary concepts that we focused on are highly important. And so if you feel that your students have not had enough practice with them, go ahead and use this handout to give them more practice prior to getting to weeks 10 and 11 in the program. I want to thank you for coming online with us, and you can give me a happy face if you'd like to stay online for a further discussion, or clap or thumbs down depending on how much you enjoyed our little session today. Our next session will be on October 20th, where we will be focusing on lesson 10.1, which is expressions and equations. And if you'd like to stay online, that would be great. Or if you'd like to give any feedback to the session, you can email me or verification for attendance, please feel free to email me as well. Thanks a lot and have a great day.